and we are moving to the new one. So we are now going to do what we call integration of rational function. So that will be the next. So integration of rational functions. Actually, in the note is 2.4. Integration of rational functions. Of course, rational functions of trigonometric function, because rational function of sine and cosine. That you are going to see what we call the T formula, or T formula. All right, so this is the next integration technique that we are going to tackle. So this type of integration is the integral of a rational function r that will depend on both sine x and cosine x dx. So this is the type of integral we are going to compute, where of course r is a rational function of sine and cosine. That's what it means, right? An example of a cosine, something of that form, maybe we can write maybe sine x like this over 1 plus cosine x. So this is a rational function where you have, it depends on sine x and cosine x, right? You can even have the square here, the square there, or minus whatsoever. Many other forms, right? That's just an example of something that you can see. So we are going to use for this type of integral what we call Weierstrass substitution. So the Weierstrass substitution, when we say T formula, this T actually tells you when you have a rational function of sine and cosine, you always use a T. Of course, let lower T, right? Lower T is the substitution. Like here in the previous example, you see that our substitution, we use this substitution x equal to a sine u, a tan u, a sec u, right? So that's our substitution. But in this case, our substitution will be t equal to, or a half angle equal to t, or t equal to the tan of a half angle, and we transform to write our cosine and sine in terms of that t. So that is exactly what we are going to do. So let me open a new page, right? Okay. So Weierstrass, so I will write here. So the Weierstrass substitution, Weierstrass, it's a German, Weierstrass. Okay. Weierstrass. I hope it's well spelled, or we correct that. Vi. Okay, Weierstrass substitution. So our T is the tan of half angle x by 2. Or we can say tan x by 2 is T. It's the same thing. This is the T. So this allows us to change R to a form we know how to handle, right? So this substitution allows us so this allows us to change the expression of R, that is R as function of sine and cosine, which to a form that we already know how to handle. We have already learned how to handle. Okay, so let us see that step by step. How are we going to transform? Because we know already that in our expression of R we have sine and cosine, and this is our T. Do we let T to be in this form? Now how do we replace sine and cosine in our expression so that it will depend on T only? Right? Okay, so for that purpose, from this expression of tan of a half angle x by 2 equal to T, if we differentiate this, right, because in our integral we have x, of course sine x, cosine x, so everything is in terms of x, and then we want to change from x to T, right, by taking of course tan of the half angle. Here we have full angle x, but we want to take the tan of the half angle to convert every expression into T only. So from this expression, if we differentiate, we know already, obviously before differentiating we can even extract the expression of x with the tan inverse. So we have x to be equal with tan inverse, and then we multiply by 2, so it will be 2 into tan inverse of T, because we apply it to T here, tan inverse of T. And now from this we know already what is the derivative, or the derivative of tan inverse. Remember we saw that the derivative of tan inverse x is 1 by 1 plus x squared. So with T, so if we differentiate this, dx will be equal to what? So we still have these 2 which will be in the numerator, and in the denominator will be 1 plus x squared, but what is our x here? Will be T, so 1 plus T squared. So when we differentiate the tan inverse function, of course because there is dx here, there should be dt on the other side, so this is dt. And similarly, we can find the expression of sine x and cosine x, right? So we have that, and the expression of sine x is 2t into by 1 plus t square, 1 plus t square, and also cosine x is equal to 1 minus t square, 1 minus t square by 1 plus t square. All right. So this is what we have. So if you recall the triangle that I draw here, I can do something similar, but this time we are going to use our half angle here. We're going to use our half angle, and we write the various expressions. So if I do something similar, we are going to use for our case the following rectangle. Okay, so this is our angle, half angle x by 2, and we know that tan is what? Opposite over adjacent. This is adjacent, so if we take adjacent to be 1, opposite will be this one, so this will be our t, and t is the tan, right? And we know that what is here, it will be the square of this plus the square of that. So 1 square is 1 plus t square, so this is square root of, okay, let's write here 1 plus t square (1 plus t square) Great. So this is what we will be using. So we have tan of x by 2, which is opposite of hypotenuse, meaning that t is tan of x by 2 for the half angle. So this is going to play an important role in all of our computations. So we are going to look at some examples. So examples on how to use these various this substitution, replace sine and cosine by these values, and use this at the end to go back to the original variables. So examples. So the first one, Okay, first example, that's 1. Determine the following integral. We have the integral of the function 1 by sine x. So we want to integrate this. So you know that by if you just use what we already know, we will not be able to do that. But if you use this, if you take our r to be 1 by sine x, right? You see that it depends on sine x. Of course, cosine does not appear. We can see that the coefficient or the factor that will multiply that will be 0, something like that. It doesn't appear anyway. But you can see it's still a rational function of sine and cosine. Right. So, as we know already, we can let that's on top there. So we let t to be 10 of the half angle x by 2. We know already what sine x is, right? We know that, of course, we can first differentiate this dt, because we need to replace the dx from here. So dt will be 1/2, right? So we apply the chain rule. Okay, now the derivative of 10 is sec squared. We know that. So that will be sec squared of the inner function x by 2. Dx. So this is the dt. And now from there, we can extract our dx, right? This dx will just be dt divided by this expression. But we know what sec square is. It's just 1 by cosine. So we can get our dx by multiplying dt by cosine square directly. So so this implies, so we can write it here. So this implies that our dx, we can extract that. Right, this is of course there is this 2, we multiply also by 2, so it will be 2 into cosine square x by 2 dt. And we know what our cosine square x by 2 is. Or actually, from the above here, if we square this expression, it will be, this is expression squared. We have this expression. So we squared this, and we squared this one. So if we square that, we have the following. So this is equal to 2, 1 minus t squared by 1 plus t squared. So it is this squared dt. Is it possible to simplify that expression? Can we simplify that further? No. We can't really, I mean, all right. Now, how do we write our sine function in terms of t? We can write this. We know what is sine of 2 angle. If we have a double angle like this, sine of 2x, we know from trigonometry, or I can simplify it. I can just write this and write that in terms of twice the angle. So it's sine 2 into x by 2. Good. So if I cancel out the 2, it's still this. So this is 2 and this is an angle, right? So sine 2 angle, it will be equal to 2 times sine and cosine of half angle. So sine 2 times sine of the angle, which is x by 2, into cosine of the same angle, x by 2. We know from here, from the above, that sine x by 2 in terms of t, so we first have this, right? And sine will be 2t right, from this expression, 2t. Oh, sorry, there is a... Okay, so this is the one that... Wait, what is going on here? So why did I use... No. I shouldn't have substituted with... Because here we have half angle. Here is half angle. I mean, what I use here is wrong, because I use with the half angle and I substituted for full angle. Here in our formula we have sine and cosine of full angles, not half angle. So it's not correct what I did there. If you want to write that in terms of half angle, it will be completely different. So what I substituted was not correct. This is x, whereas I use x by 2. So we can come back here. Because we know that this but it's nice. Okay, I will quickly write the formula here, because we have the cosine of half an angle and sine half an angle here. So we can quickly write the formula here, because those are the formula we'll be using. So it's good that I realized. So from here we have sine x by 2, right? From here it is opposite by adjacent. Opposite adjacent is this one. So it will be t by square root 1 plus t square. And for the cosine, it will be adjacent. That's 1 by the same thing. So for the cosine, so cosine x by 2 will be 1 by square root of 1 by t square. All right, so I will change what I wrote here was not correct. Okay, so because I'm going to square this for the cosine, I'm going to square this, so it will be 1 by 1 plus t square. So that will be 1 by 1 plus t square. So these two, I can put the 2 here on top and erase it from here. Okay, so it is correct now for the dx. Okay, now here sine x by 2, we saw that it's the opposite, which is t opposite 1 plus t square square root of that, and the cosine is 1 by square root of 1 plus t square. Obviously the product of the two, I will get rid of the square root, so this will be 2t by 1 plus t square. Of course, need to rearrange that properly. 1 plus t square, like this. Great. So we have our expression of sine x. So sine x is 2t by 1 plus t square. So we just substitute that back into our integral. So therefore, or thus, the integral dx by sine x will be equal to, so this is dx, 1 by, so I will take the reciprocal of this. Of course, it is like I write 1 by sine x into dx. So 1 by sine x, I take the reciprocal of this. So that is 1 plus t square by 2t into, now the dx is this expression, 2 into, sorry, by 1 plus t square into dt. So we can see that 1 plus t square here, we cancel with the numerator. These 2, we cancel with these 2. So we are left with dt by t. So this is equal to the integral of dt by t, which is nothing else than ln of absolute value of t plus a constant, but we know already what is our t, the t formula. It's tan of the half angle. So that is, this is equal t, it's ln absolute value of tan x by 2. Now this depends on x, right? We have our x there. So, and that is it for this first example. So we know already how to do this type of integral. So similarly, we are going to do the same thing with the cosine. So 2, the first one, okay, 2. 2, so we are going to do the same thing. Determine the following integral . The integral dx cosine. You see that it will be similar, right? It will be similar. We have already, so we are going to use the same we are going to use this I will only express. So we are going to use t and dx. They are the same. They are unchanged. I'm only going to rewrite cosine x in terms of t, right? Cosine x. So similarly, I would just say similarly. I will not repeat everything. Similarly, that is, I follow the same procedure as above. Similarly, I can write cosine x, right, in terms of sine or cosine of half angle. Okay, so for the cosine x, there are many ways to express that. I can write my cosine x as cosine 2 into x by 2, right? And the cosine of half angle, there are many formulas. I can write that as cosine square x minus sine square x. That's one way. Or I can write it as 2 times, right? Okay, let's use this one. It's almost the same thing. Cosine square x minus sine square x, right? We can write this, sorry, ix by 2, because this is our, yeah, like this, like that, yeah, because this is our half angle. Or we can also, if you want to write just in terms of cosine or just in terms of sine, we can do the same thing, because even this sine, we can write sine as 1 minus cosine. 1 minus cosine, then it will become 2 cosine. So this is the same as 2 cosine square x by 2 minus 1, right? Because if I replace this one with 1 minus cosine square x by 2, you see this negative, and the negative will become 2 times, and then the minus 1, right? Anyway, we can use either, but at the end of the day, we'll have the same formula. So I just substitute. So this is equal to 2 times. Now cosine, the cosine of an half angle is this one. So it will be 1, because we square it, will be 1 by 1 plus t squared, right? So 1 by 1 plus t squared, like this, minus 1, right? Which we can still write as, okay, let me write it here. Now if we cross multiply, numerator I have 2. This 2 minus 1 will be 1, right? So this will be 1. Now the negative times this, and that will be 1 minus t squared by 1 plus t squared. Right, so that's cosine x. Give us that expression. 1 plus t squared plus 1. But it was already here. I don't know why I wasted all that time. Yeah, it's because here. Wait. Even that 2t sine x is 2t by 1 plus t squared. 2t 1 by, of course. Here I only wrote the formula, right? I only wrote the formula here. I wrote the formula here. But here we are actually, we show how to obtain the formula. Yeah, exactly. So it's not a waste of time. Here I just plug the formula. But here I'm giving the steps on how to obtain the formula. Great. So we already know those expressions, how they are obtained. So they are here. We just substitute that into our integral. Okay, so thus, we just substitute that. Thus, this integral, I'm going to substitute everything. So if I take the reciprocal, this, okay, let's write that. dx by cosine x is equal to the integral. So I will first take the reciprocal of cosine x, that is 1 plus t square. 1 plus t square by 1 minus t square times dx. And dx, we know already the expression of dx. This is the expression of dx, right? This entire expression. This is our dx. Copy and paste. No, that is not beautiful. What is that? Where is the dx? Okay, 2 by 1 plus t square. 2 1 plus t square dt. As above, so we simplify, we cancel this out, right? So it's equal to the integral so we have 2 there, 2 dt, and then 1 minus t squared like this, right? Right, so we have 2 here, and partial fraction will help us because we can factor this. So we use partial fraction. So if you use partial fraction, it will be 1/2, 1/2, and then with the 2 we multiply, so we get finally integral of 1 by 1 minus t plus 1 by 1 plus t dt, right? So if we cross multiply, it will give us exactly that. Cross multiply this times that will give us 1 minus t squared. Now cross multiply will be adding these 2 terms, so negative t will cancel out with t, and 1 plus 1 will be 2 in the numerator. So that's exactly what we have. So this is dt by that, dt by that. Okay, for the dt here, we need to put a negative in front here, because if I differentiate t, it will be -1. So there will be a negative here, and I put the same negative here in front to balance. So there's this negative here and the negative there. So this is a d, right? Okay. So finally, this will give us negative ln of the absolute value of 1 minus t plus ln absolute value of 1 plus t plus constant. Obviously, ln of this will be the ratio 1 plus t by 1 minus t. So this is equal to the ln of the absolute value 1 plus t by 1 minus t plus a constant, and we know the expression of t. T is tan of the half angle. So finally we have ln of the absolute value of 1 plus tan x by 2 by 1 minus tan x by 2. plus a constant. So this is the final a lot of computations, right? A lot of computation. And finally we will do the last one, and we will stop. Maybe. Yeah, I think we will need to stop after the next and the last one. So this one, 3. Determine sorry, this integral 1 by sine x plus cosine x, sine x plus cosine x dt. Of course, we are going to use the t formula. So as usual, so using the t formula, so we let, as usual, t to be 10 x by 2. We know the expression of each. We know already that sine x will be 2t by 1 plus t squared, and cosine x will be 1 minus t squared by 1 plus t squared. That's what we saw from the previous examples. Now if we add the two, if we add sine t plus cosine t, sine x plus cosine x in terms of t, we have the same denominator, so we'll be adding all these terms here, so that will be 2t plus 1 minus t squared by 1 plus t squared. Okay, now what we need to do here, we need to compute our dt, because and the reciprocal. So the reciprocal, so this one, so this implies that the reciprocal 1 by sine x plus cosine x will be equal to 1 plus t squared by this expression Okay, but this expression, how can we easily rewrite it? If we can write this as a square, because if we know already, we know that if we write t minus 1 square, t minus 1 square, because we have this one and then we have this square, so there will be a negative here in front. So this is t squared minus 2t plus 1. Then if you put a negative sign here, there will be negative here, positive there, and then negative here. But we have the 2t which is there, and we have the negative t squared. But we need plus 1. So if I add 2 here, plus 2, then this becomes 1. And finally, we have this expression. So if you take the reciprocal, it will be this by the numerator here, which we can rewrite as 2 minus t minus 1 squared. Great. So I can delete this one. All right. So now what is our dx? We know already from the above that dx, where is that? Is 2 by 1 plus t squared dt. Okay, so we can substitute that directly. Thus, the integral of this expression dx by sine x plus cosine x is equal to the integral of this expression 1 plus t squared by 2 minus t minus 1 squared times dx, which is 2t by 1 plus t squared. So the 1 plus t squared will cancel out with the 1 in the numerator. So the final integral will be the integral. Of course, I can take the 2 out of the integral sign. Of course, there is the dt that is missing. I didn't write that dt. So that will be 2t by this expression. 2 minus t minus 1 all squared. Right. Of course, these 2, I can take the 2 out of the integral sign. And that is it. So this is what we have. I can take that 2 out, so it doesn't, I hope it doesn't hurt anybody. It doesn't hurt. Right. Okay, now with this one, what can we do? Because we are not yet done. We need to integrate that. And to integrate that, if you recall, this is like the denominator is in the form of the form okay, so you have a term here which I can write to be a constant term, and then we have a variable that we are squaring. So it's something of that form. And for this one, if you recall, when it was positive here, we used the 10 inverse. Of course, in the change of variable, we will use x equal to 8, 10u. But when it's negative here, it was a sec, right? And now, if we change the position of x and u, yeah, it's when we change the position of x and u that we have the sec. When it's like this, it's as if we have 1 minus and then the square root. That was sine. So we'll be using the sine. So for this one, For this one, we'll be using our x. So substitution does, so this implies the substitution x equal to a sine u. So that's the type of the change of variable that we use. So in our case, this whole expression is like our x. So if we say x equal to, actually this x is our t minus 1. So that is our x. So x in our case is t minus 1. X is equal to t minus 1 in our case, right? Because all this, we call it x. And just to see which change of variable to use. It's not secret. Okay, so that is it. We are done, right? So, and what is our u? Square root. So, and a is equal to square root of 2. If I square this, I get this, right? So this is our a, square root of 2. So we have already 2 change of variables, so we will perform that twice. All right, so we need to use that to complete the work. And how do we perform our work? It is just easy. Right, okay, so let's proceed. And at the end, we write everything in terms of x, that is in terms of t, and t, we know what it stands for, 10 half angle. Obviously, when I say x, this x is not the original x, right? Please, we should not confuse. Okay, let me quickly change that. Instead of calling that x, we replace with y, so that we don't confuse this x with the original, right? This x here is not the same. So to make things simple, I would just yeah, maybe we can use capital X. And then we know that capital X is not lowercase x. So let's write capital X like this. Capital X, which is different from the original. And that capital X is actually... Alright, good. So that's what we are doing. We're going to use this. So we know already what dx is in terms of du, because we are going to write everything in terms of u. So d capital X will be equal to a cosine u du. What else do we need? That's all. Now going back to the integral, whence this integral dx by sine x plus cosine x will be equal to, so you have the 2 here, then the integral dt, okay, here we have our dx. So dx is the same as dt, right here, because this is a capital X. Let me write it here. So from here I can write that d capital X is equal to dt, because the differential of -1 is 0. So d capital X is equal to dt. So I'll write that this is dt. Okay, so it's 2 times. Okay, so dt is the same as as a, of course, so that is equal to, so a is square root of 2 cosine u du. Right, so that is our dt. So I will substitute it here. So we have square root of 2 cosine u du. That is for the numerator. By, now in the denominator, this one we know already, t minus 1 is what we call capital X, and capital X is a, so this is 2 minus, we are going to write x squared, so that will be a square, which is 2, so that will be 2 sine square u. Now I can factor by 2. If I factor by 2, be 1 minus, this is 1, and then we can close here. Okay, so this will be, I will cancel out these 2 with this and that. So we have square root of 2 cosine u du by, now here we have 1 minus sine square u, and this one is cosine u. Right, now this is cosine square u. So this cosine square u will cancel out with the u here. So here we have square root of 2, which I can factor it. Now here I cancel the cosine and the cosine squared, and then become du by cosine u. Du by cosine u. But we computed this previously. This one, du by cosine u, is this this one, right? So we know already the expression of that in terms of so we replace x with u, and u here we have this result. So wherever we see x, we replace with u. So because we have learned, I mean we ended up here, so we will just copy this and change x into u. There's nothing we can do. That's exactly what we are obtaining. You cannot manipulate it otherwise. So we just say that this is equal to this, but with u here. So this is u, and this is u by 2. Absolute value. But what is u? Obviously, if we want to compute u will be sine inverse of x by a. We put it there. X by a, we know what x is. Please, I plead with you to check this again to make sure that it's correct, right? Because this is cosine, you will not cancel out. We have the cosine here, which is not squared. And we have the square here. So if we cancel out, cosine will remain in the denominator. And we have already done that. We just substitute, right? So now if you replace u by this value, I can write here that u is equal, Okay, let me write that with the blue color. So u from this expression is sine inverse capital X by a. And what is a? A is square root of 2. And even the capital X is t minus 1, as you can see here. So this capital X is t minus 1. So I can replace that. So this is t minus 1. And t itself, because we have to go back, where did we let? And it's 10 again. 10x by 2. Now we are going to the original x, which is x by 2 from here. So you see that the expression is really a long one. So this will be equal to, we'd write ln absolute value. We're going to write everything properly, right? 1 plus 10 of what? Now u is this sine inverse of what? T is 10 x by 2 minus 1 by square root of 2. I close. So that is our sine. So 10 of u, so this is u, and we divide that by 2 again, right? So this divided by 2, and then I close the argument of my 10. And we repeat the same thing. 1 minus minus 10 of this whole expression sine inverse of the 10 of x by 2 minus 1 by square root of 2. So this sine divided by 2, so I will just divide it here and close the argument of the 10 and close the absolute values like this, plus the constant c. Great, so that is our final expression. It's really long. It's really long. Yeah, so that is it. Step by step, please, I encourage you to go through step by step and make sure that you understand what is going on here. So I'm going to stop here because it has been long. So it is better to stop here to allow you to go through all these computations yourself. And I will record another video so that we can quickly cover before tomorrow class, because tomorrow we are meeting face to face. Okay, thank you for your kind attention. God bless you and see you next time. Bye-bye.